Hello, welcome back, teams. We'll just wait about a minute or so and we'll get started with the presentation. So if your teammates are still they are yet to join, just let them know that they can join soon and we can start the presentation. So hello teams, welcome back to the module 2 of today's IPG carmaker training session. So hope you have had a great lunch. So in this module, we'll be covering the software characterization specific to Bahabagi. So before we move on towards the simulation aspect, we'll revisit the e-bar powertrain parameterization, which was remaining from the last yesterday's session. So we'll be covering that. So for the e-bar powertrain section, so this will be covered by Anuka from e-bar tech team. So over to you, Anuka.
Hello everyone, good afternoon. So I'll be taking the eBaha powertrain parameterization. I'm sharing my screen. Just let me know once it's visible.
Yes, it's visible.
Okay. Uh, okay. So let's start with the basics of the eBaha powertrain parameterization. So as you can see on the screen, once we are there under the powertrain module, you have the engine structure which is there. So it is basically for the mBaha teams. Now, the first and foremost step that you have to take care to model your motor and all the other models for your eBaha powertrain, you have to go under the models tab, and instead of conventional powertrain, you have to shift it to electrical powertrain. So as you can see, once I selected the electrical powertrain, the configurations have changed. We have an electric motor over here now, and now we have the eBaha powertrain. So this is the first step that you have to take care. Now, once you have entered into your EBAHA parameterization module, now according to your teams, you can select what is the number of electric motors that you are using. It can be either 1, 2, 3, or 4. So what I will be doing is, first I'll explain each and every sub module, that is the drive source, drive line, power source and control unit, based on if you are having a single electric motor. And once I'm completed with all of these, I'll just tell you the minor changes that you have to do if you are having 2, 3, or 4 motors. So let's start with the one electric motor. So you can directly go to your next tab, which is drive source. Now there are two different modules. So here you can model your gearbox, and you can model your electric motor. So let's start with the gearbox. So as you can see in the gearbox, we have the model selection parameter first. So if you can see, there are different gearbox styles that we can select. There is manual, automatic, automatic with converter, DVA, and no gearbox. So for the teams which are having a single speed gear reduction ratios, kindly select here no gearbox, and you can select your gear ratio in directly your axle part. So that also I will be showing where you can add. So you can select directly no gearbox over here. And once you are modeling your drive line, so in case you are using a front axle or rear, you can directly write your gear ratio in the transmission box. So this is one of the things that you have to take care if you are having a single speed reduction gearbox. Now in case you are not having a single speed gear reduction, and you are going for a CVT or some other kind of gearbox, then you have to model it and you have to add it in terms of C codes, or MATLAB and Simulink codes can also be used over here. So that's the first thing that you have to do. So I'm going for a single speed reduction gearbox. So I've selected no gearbox. Now once that is done, I'll go to the electric motor, and then I will first model my motor. So again, for modeling your motor, you have two different options that you can select. Uh, like, not two, here only we have the one option. We can directly use the 1D lookup tables. So now there will come different values that you will have to enter to model your electric motor. So first is the inertia, that will be your motor inertia. That next will be your ratio. So this parameter ratio is basically a constant transmission ratio, and it is between the electric motor output shaft and the driven shaft where it is connected. Next is build up time. So how much build up time your load signals are taking. And next is the friction coefficients. So obviously you might not be remembering the exact definitions or what does these parameters means. So for that I would suggest that you can directly go to your user manuals, and you will get each and every definition that what does that particular parameter mean. And as you can see, you have the ratio, inertia, build up time. So just go through these definition once to understand that what you have to put as the values. So once you know what does that parameter mean, you can directly fill up these values. Now in case you are not having the build up time and the friction coefficient values from your motor supplier, then you can keep these two values as default in the software. Also, you have to note down that whenever you are submitting your models, this ratio value has to be 1, because the same output is always used at your wheel ends and your motor. So there is no differentiation over here. So this value always has to be 1. I think it's clear. Next will I'll make you understand what's the voltage levels you have to select. So basically, this voltage level will be specifying that which electric circuit your motor will be connected to, or the power supply your electric motor will be connected to. Since we are using a high voltage motor, so you always have to select high voltage 1 as your option. So this is the default option that you have to select high voltage whenever you are submitting. So now once you have done the general parameterization, next you can parameterize using your torque values. So here you will have two different models how you can do this. First is the characteristic value, and second is the 1D lookup table. So first I'll explain with characteristic values. So in the characteristic values, here directly you can input your mechanical powers, your torques, and if you want to parameterize like this, you can select the 1D lookup table, and you can see you have different tables. So here there is rotational speed, and then there is torque. So according to your rotational speed, whatever corresponding torques are there, you can create a small table. You can add your default values. It can be your own value depending upon your own motor. You can add those values, and accordingly the curve over here will be changing, so you can even visualize your curve. Next is the amplification. So in case I want to amplify my curve for different trials, I don't want to enter the values again, just want to test how it is working. So I can change the amplification values from 1 to 1.5, 2 or 3. But you again have to take care that whenever you are submitting your models, the amplification has to be 1, and after your trial and error you can only change the rotational speed and torque values. Kindly keep the amplification as 1 only. So these are the two different methods how you can model the torque values. Now again, there is generator model. So this model has to be done only for the teams who are using regeneration. In case you are working with regeneration, then you can similarly fill up your mechanical power, maximum torque, maximum rotational speed or rotational speed. You can do it with the characteristic values, or you can go to your 1D lookup table. There are these default values. In case you have your own regeneration values, then kindly change these values over here and let the amplification be 1. In case your team is not going for regeneration, then please use the amplification value as 0, and also replace all the rotational speed and torque values to 0. So this is one of the thing you have to take care. And for the teams who are not using, amplification can be 0, or you can directly keep mechanical power as 0. So these are the two different options. Next is the efficiency tab. So here you have to enter your motor efficiency. Now again, in case your motor efficiency is 90%, then you can add only that value in case you have a valid document which is showcasing that your motor is 90% efficient. If you are not having that particular valid document from your motor supplier, then you are recommended to use efficiency value as 0.85 only. So this you have to take care that in case you have the document, only then change this value. Otherwise you have to keep the efficiency value to 0.85. Then the say next thing is for the regeneration. In case you are using, then you can add your regeneration efficiency value here. Next is your motor mass and the inertia values. So these are the default 0 values. So you have to enter it according to your own motor, that you what's your motor mass. Suppose it's 10, so you can add directly 10. And according to your motor, you have to even write the inertia values. So this you have to add up over here. So now we have modeled our gearbox and electric motor. So let's move on to the drive line. So first we'll go to the general tab. Here we have different kinds of driveline options that you can use. In case you are going for a front drive, you can select front drive. In case rear drive, you can select rear. Or in case all-wheel drive, you can select the all-wheel drive. So I'll explain with the front drive that how it works. So this is the first option that I have selected. Next, you have to also take care that there is an option of flexible driveline. What does it mean? I'll explain. But whenever you're submitting, you don't have to check this. So this has to be always unchecked whenever you're submitting your files for evaluation. Also, there is external torque off option which we have to select, since we are not providing any external torque other than motor to our wheels. So this is a default option that we have to select. We don't have to change this because we are not providing any external torque. So kindly take care of this. Now suppose I have selected front drive, so I can go to my front axle and I can directly provide the inertia at my input shaft, inertia at my output shaft, inertia of my cage, and I can provide the efficiency and transmission. Transmission, as I suggested, since I'm explaining with single gearbox reduction ratios, so since there we select a no gearbox in the drive source, or in the gearbox part, so you have to add your gear ratio in the transmission part. So I think it's clear. Next is the efficiency. Again, you have to make sure that efficiency has to be kept as 1 only. We are not changing this over here. Next is the transmission part. Next, if I'll just explain in case you are going for the flexible driveline. So as you could see, if the flexible driveline is on, I have even the option of changing the drive shaft values. I can change the stiffness, damping, and inertia values. So as of now, for these submissions, you don't have to do this. Flexible driveline has to be unchecked. Now, in case you are having the rear drive, so the rear drive axle component will be on. So you can go to rear drive and you can select your inertia in, out, inertia cage. Again, the transmission axle ratio and the efficiency has to be kept as 1. So this is how you can model. Now again, if you're going for all-wheel drive, so you will have different options. The front axle you can model, you can model the rear axle, and additionally you will have to model your differential center. Now in this case, just to understand that how you have to put the values of gears, the ratios, and the efficiencies, or how you have to select your mountings, you can always refer to the user manual. So this is how we have to do. So I'll keep it to front drive. Now, in case I'm going to the next part, that is the power supply. So now we have modeled everything. We want to provide the power supply. So again, for the power supply, we have three different options: low voltage plus high voltage, or we can have low voltage plus high voltage and plus high voltage too. Now in this, the default or the main value that you have to keep for sure is low voltage plus high voltage 1, because we are using a high voltage 1 battery. So that's why we have to keep this only as the option. So this you have to keep. Now once you have selected your power supply model, that is low voltage plus high voltage, so this is like a rule, you have to keep this only. Next, you can write down your auxiliary consumptions on the low voltages, whatever watts you are consuming in this particular tab, that how much ever your consumption is there on the low voltage and how much ever your consumption is there on the high voltage. Since this is auxiliary consumption, so take care that this is other than your motor, whatever high voltage consumptions you are having, you have to write over here. So now once you have selected the type of power supply, you have to model your batteries. So again, we have given two different options. For the low voltages, if you are using two different batteries, a low voltage battery or a high voltage battery, then you can model it directly here. You can model the LV battery and the HV batteries. Suppose in case you don't want to use two batteries and you're using a DC-DC converter, so there's a choice between DC-DC converter and low voltage battery. So according to your team, you can select which one you want to go for. So one by one, I'll explain how you can do that. In case you're going for a DC-DC converter, then you can directly write your maximum converter power and your efficiency values in these tabs. Now, in case you are not going for a converter and you are going for an auxiliary low voltage battery, then keep this as 0 over here and go to your LV battery. This is the standard model that we have, Shen battery model. So don't change this. Only change the values in the tabs over here. Now, suppose you have to write the capacities, ideal voltages, initial state of charge, and the other values. So ideal voltage in this is nothing but it refers to your nominal voltage of your battery. So you have to take care whenever you are modeling your low voltage batteries, the nominal voltage always has to be less than 15 according to your e-Baha rule book. So always refer to your Baha rule book whenever you are writing these values. So this cannot cross 15 and it cannot even be equal to 15. It has to be always less than 15. So that you have to take care in your mind that you're following the rules whenever you're modeling these particular parameters. Now, next you might have doubts at how you have to fill the values of RO, R1, R2, C1 and C2. So I'll just explain this. So for to understand first of all that what these values means, we'll go to the reference manual and we will see the battery model Shen to understand that how has the equivalent model of this particular battery has been there in the particular car maker software. So you'll get the details at 466 page. So you can just go through this and understand what and are not values. So you can see the model and compare it with your particular battery, or your battery supplier might have given you these values and you can write down. Now, suppose in case your battery supplier has not given you these values, then you can keep these particular values, that is R0, R1, R2, C1, C2 as default values. So don't change these values in case you don't have the value. So be careful about that. Second, there is an option of state of charge influence to ideal voltage. So this basically refers that according to your SOC state of charge, you want the nominal voltage to be changed. So we don't want that at present. So we don't have to check this. So this has to be kept as unchecked. So be careful about that also. Now at the bottom you can see the maximum power of your battery. So since we have always already specified what should be the maximum power, so you have to also be careful about that whenever you are filling up this maximum power in the low voltage battery. Again, once you have modeled your battery parameters, you have to write down your battery mass and you have to write down your battery's inertia values. So this you have to write down according to each and every team's particular batteries. So this will be specific to your teams. Now, once you have modeled the low voltage batteries, next comes is the your main battery or the high voltage battery. So you have to again keep the same model as Shen. The only things you have to change is these parameters. Now again, whenever you are writing your ideal voltage or the nominal voltage, according to Baha rule book, it always has to be less than 60. So be careful whenever you are writing the ideal voltage. It should never be crossing 60 or not even be equal to 60 volts. So that's one of the things you have to take care. Second is the capacity value. Even the capacity cannot be crossing 120 Ah according to your rule book. So refer to your rule book whenever you are filling up the capacities and the nominal voltage. Your battery selection should be under the EBAHA rule books only. When it comes to the again the resistances and the capacitance values, you can keep these as default in case you are not having the values. Otherwise, refer to the reference manual and according to your particular battery, kindly fill up the values. So this is how you have to do. Now here comes the maximum power in terms of the high voltage. So as we all know that the maximum power for the motor is also 9 kilowatt. So according to rule book itself, we have to take care that the max power that we are keeping over here is 9 kilowatt and it is not crossing that. So you have to always keep 9 over here. That can be the maximum kilowatt your motor can be, and your power also can draw the similar power. Next, again, as I said, that the state of charge has to be kept as unchecked because we don't want our state of charge to influence our nominal voltages or ideal voltages. Now, once you have modeled the battery, again, it's your mass and inertia. So you have to fill up these values according to your batteries. So you have to fill up the mass values and the inertia values. So we have modeled as of now our power supply. So we'll go on to the next tab, which is control unit. So now we want to control our motor and the whole performances. So how do we do that? So we have to go to the control unit. In the general model, first we have to select the control part. So there is generic model and there is electric model. So you can either keep it as generic, but since we are working with eBaha, so we would refer you that kindly use electrical. So if you use electrical, you could see that the gas interpreter model is directly on. So gas interpreter is nothing but your accelerator. So it automatically gets checked. This is default now because we are working with electrical. There are two different options which you can choose. Either you can start your motor, since we are working with electrical, so this is directly refers to your motor. So you can start your motor with the key, or you can start your motor with a button. So this is how your motor will be getting on and off. So next is, I would choose starting my motor with the key. So I have selected this option. You have freedom to select whichever option you want. Next is operation state machine. So this basically tells about what's the state of your machine or your car. So like it is on or it is off. So you can keep this as however it is. That is the generic. Don't do any changes over here. So we suggest you please keep it as generic only. Now, once I have selected my accelerator, let me go to gas because I want to now two different values that we have to fill up. So you have to fill up your max torque at the full gas or full acceleration, and then at your zero acceleration, what's your minimum torque. So you have to fill up these values. So once you have done this, then you can directly go to your battery. Now here the battery management is checked, but you could have filled these values. But since we don't want any differentiation, and we want all of the teams to be at equal level, we don't want any additional discharge from your batteries. We want all your batteries to work properly. For that reason only, that we don't want any additional discharges, kindly keep this as unchecked. This is only for the virtual round. So this is only for the car maker. Whenever you are submitting the models, don't select the battery management. We don't want you to model this, so it has to be unchecked. So this is one of the things you have to take care. Next is the regeneration part. Now again, this is only for the teams who are working with regeneration braking. In case you are not working, then you can kindly uncheck these values. Now suppose your team is working with regeneration, then you have to fill up these values: your SOC limits, your range, your speed limits, and your torque limits. So all these values has to be filled up by the teams who are working with regeneration. Also, now your team is working with regeneration. Just selecting regeneration in the powertrain module will throw errors. The reason is, if you go to brakes, for now you had selected no regeneration. So in case you want to use regeneration, then don't forget to go to your brake module and change your regeneration brake mode from no regeneration to either a parallel regeneration kind or a serial regeneration kind. Now again, you might have doubts that what is serial and parallel regeneration. So you can go to your users guide, and you can refer that what does that kind of model refers. So as you can see in the regeneration brake mode, there is a parallel and there is serial. So in terms of parallel, basically there is a constant distribution of brake torques between your regenerative braking, that is electric motors, and your hydraulic braking, that is your brake system. So it's a 50-50 distribution. Whereas in terms of serial model, the electric motor supply as much as of the demanded brake torque as it is possible, and once that is over, only then to satisfy the brake torque is the hydraulic brake system torque is used. So there's a difference. So just go through these different models once before you are modeling your values. Again, you might have confusion of what is your brake torque p values, then what's your recuperative brake torque values. So for all of these, you can always refer your user guide. Now, suppose you know what all of these values means. That's your brake torque control P value and I values. Then you can directly fill up your these values according to your particular regeneration module. In case you are not having these values but you are using a regeneration model, then keep these as the default values. So always remember, you have to go to brake, control and change your regeneration brake module from no regeneration to either parallel or serial. So only then your regeneration brake would be working. Otherwise, whenever you are running simulation, you'll be having errors. So suppose you are using regeneration. I have explained both the points. Now once that is done, you have to go to your next model, that is your transmission control unit. So there are different options over here. So as you can see the different options. Now as I have not used the gearbox, I have directly written no gearbox in the gearbox, and I use the gearbox value or the gear ratio value in the transmission part directly. So I don't want any transmission control unit. It's a single speed that I am using. So for that, you have to specify not specified over here. Don't keep it as however it is, otherwise you'll be getting errors when you are running your simulation. So according to yours, in case you are not using a single speed, you can always select your type of transmission control unit. In case you are using a single speed gearbox, then kindly use not specified over here. So I will be using not specified for my transmission control unit. Now once that is done, I will move to my motor control unit. So you have to keep this as basic. Don't change this. You have to keep this as basic only. Then for the electric motor, you can always see the motor torque P values and I values. Again, these values has to be according to your particular motor. So suppose your supply has not given you these values, then you can keep these as default. Whatever values at present are there, you can keep the same default values from your car maker. So this you have to take care. Now next we have to go to the battery control unit. So again, since we have used for our power supply a low voltage plus high voltage one, so the same has to be selected even in your battery control unit, because we are using the high voltage batteries. So take care of this also. It has to be low voltage plus high voltage one option only. So these are the things how you can parameterize your whole eBaha electric powertrain. Now let's go back to the general tab. Now I have explained everything considering that your team is using a single motor. Now suppose your team is not using a single motor and you're going for two electric motors, then what are the changes that you have to do? So I'll just directly explain. So once I selected the two electric motors, now you can see here the motors are not present. So for that you have to first pre-configure, because your motor can be in any different configuration. So go to pre-configuration electric and then two motors. Now you have three different configurations which are available. So either you're using both the motors at your front, one at left and one at right. The same can be you are using both at rear, one at left and one at right. Or you are using two motors, one at your axle front and one at your axle rear. So suppose I'm using at the axle front and axle rear option. So as soon as I pre-configure, you can see in the graph the configurations are there. So my EM, that is electric motor, is used for the front, and my EM1, that is the drive source 1, is being used for my rear. So you can directly click over here, it will move to that particular motor's parameters. So again, these are the same methods how you have to parameterize how we do for a single motor. Only thing is you have to parameterize twice. First for your front motor. So it's the same thing. Again, how I explained, the gearbox, in case you're using a single speed, go for no gearbox. And in case you're using CVT or some other kind, you can select for CVT since it is not there. So you have to do a embedded code. So you have to model in C, or you have to model in MATLAB and Simulink, and then import your models over here. Rest every single thing how you have filled up remains the same for how you do for one motor. So again, just to understand how I explained, you can directly click over the motor and these models will move over there. Now suppose again you are not using two motors, three or four motors. So for three motors, again you can go and you can see there are now three drive sources. So you can have a check over here. And now to fix your motors, you can again do a pre-configuration. Go to electric 3 motors and you'll have two different options: front, rear, or front axle with rear axle. There are two different options, so you can accordingly select how you are having in your ibaha vehicle. Suppose again, if I don't want to use 3 motors, if I'm having 4 motors, then there is only one option, that is your wheels. Obviously you'll be using all wheel drive with your hub motors. So if in case we are going for hub motors, then they are using 4 electric motors, then you can use directly the 4 electric motors configuration. You can select the em2 if you want to model. You can select your em3. So for better understanding, always refer to this configuration diagram so that you can model your each and every drive source or your electric motor properly, so you don't get confused that which motor you are modeling. So be careful about all this. uh, yes, so these are the different methods how you can actually model your powertrain. So yeah, I think that's all from my side, Aditya.
Thank you, Anuka.
Yeah.
Yeah, so just a quick side notes here regarding the CVT model. If you're Since you have to go ahead and make those on your own, so you can get started. So if you want an insight into how you can get started into making those models, so you can go into the reference manual of IPG carmaker. Just share my screen. So I hope my screen is visible. Yeah, so in the reference manual, there are models which are given, like how the uh, for this is for MBAHA vehicles which is present. So you can similarly make the similar models in the MATLAB, and you can link it externally also. So you can see how the TCU is parameterized here. So you can get a more detailed value of how the buildup and how all the losses are parameterized. Just go to one more. Yeah, so how the TCU is controlled. So it is as a clutch as well as a gearbox. So how it is how a combined clutch and gearbox model is then combined into a transmission control unit. And regarding the specific controls that is given here regarding the speed envelope. So you can just go into all these models which are given in the reference manual, and you can go ahead and make your own MATLAB Simulink models, and you can link them into the IPG car maker. So moving ahead, the next session will be regarding IPG kinematics. As the ATS team had already taken the kinematics part, we'll be focusing more on the uh, parameterization for a Baha buggy. So as you know that it is this is a standalone software which is used for high fidelity simulation of your vehicle axles. So you'll be able to see how you can go into the entire steps of IPG kinematics. So over to you, Ruturaj. So you can go ahead and present. Is my screen visible? Yes, yes, you can go ahead. So like yesterday, like we covered the vehicle parameterization, in which like we covered the air kinematic slide. Rudraj, sorry for the interruption. I guess your voice is a bit low. If you can speak up a bit. Okay, so is this okay? Yes. So yesterday we parameterized our suspensions using either the linear kinematic models, or by using the MBS editor. Okay, so in that we had just briefed you about an SKC file, so which is created in IPG kinematics. So now today we'll just focus on IPG kinematics part and how you can create a suspension model in IPG kinematics, which you can enter, which you can use as an input to your vehicle. Start with, I'll just open my carmaker GUI. this, just select the project folder. So yesterday we created demo underscore vehicle as a project folder. Okay. Now to access IPG kinematics, you can file and open IPG kinematics. Okay, so this is the IPG kinematics dashboard. So, so what is exactly IPG kinematics? So I'll start with this question. So IPG kinematics is a program system designed to simulate a vehicle axle on an axle kinematics test bench and is used to calculate kinematics, steering kinematics, and electrokinematics of all types of suspensions. Okay, so the axle can be parameterized with detail as a non-linear multi-body systems, and their properties such as rigidity, mass, and damping can be modified using IPG kinematics. Okay. So like similar to the carmaker GUI, so you also have a menu bar over on the top in which you have the file, edit, analyze, and help options. Okay. So in this, similar to as IPG has also provided the reference manuals or the user manuals for car maker. Similarly, kinematics has its own reference manuals. So for using kinematics, you need to refer to those. Okay, so you can access those using the help tab. In this, you'll see the reference manual. Let's open this. So this is the reference manual for IPG kinematics. Okay. So we'll go as and when we are modeling our suspension system. So we'll just go back and forth between the reference manual and GUI. And I've opened my dashboard once again. So to create a new suspension system in IPG kinematics, so to make our life easier, so IPG has provided a few default models. So you can access them using either the file and go into new, or you can also select just this new model option. Okay, so in this you'll see these various options that are available in kinematics. Okay, so I'll continue using the double wishbone setup today, as a lot of teams use double wishbone systems in their on their front axles. So I'll just click OK. Yeah. So now we have selected our double wishbone system. Okay. So let's just go to the reference manual once and see how is the double wishbone system parameterized in IPG kinematics. Okay. Yeah. So this is the double wishbone suspension system in IPG kinematics. So in here you can see that the lower wishbone and the upper wishbones are mentioned, and also the steering rod, steering rack, and these components are also mentioned. Yep. So over here you can see that the front view as well as the top view of the suspension system has been provided over here, so that you can identify which all components are present in the system. Okay. So the mechanical model of the double wishbone wheel suspension system comprises of 22 bodies in IPG kinematics. Okay, so like these are the different bodies which are interconnected uh, to make this double wishbone wheel suspension model. Okay, so in this you can see that the vehicle body is connected. And this you can see that the vehicle body is connected to your chassis subframe. Okay. So like the chassis subframe is a structure which supports the axle, suspension, and powertrain component. So this is a system that this is a structure which is normally used in the commercial vehicles. Okay. So with respect to Baha, so you don't need to worry about this. So you can just connect your systems directly to your vehicle body as we do with our roll cage. Okay. So now you can see that the other components such as other bodies such as wishbone lower left, wheel carrier left, steering rod left, upper wishbone left, and wheel left. So all these systems are connected to your vehicle body in the suspension system. Okay. So along with this, So this is the suspension side of things. So also the steering rack has also been connected to your vehicle body. The same thing is applicable on the right hand side also. Okay. So now that we have explored the mechanical model of double wishbone wheel suspension system, so let's go back to the kinematics GUI. So now we'll start with defining the calculation characteristics by using simulation control. Okay, so you'll need to define what kind of calculations you want to do in IPG kinematics forehand, so that your uh, time is utilized properly and you spend less time and you do the simulations much more efficiently. So to access that, you can go to the edit tab and go to simulation control. So now we are into the simulation control GUI. So this, so let's start with the general tab. So the general tab, you will see various options are available over here. Okay. In this, the IPG kinematics and suspension tabs are predefined, so you can't edit these. Okay. So coming on to the comment, so you can add comments to describe your models over here. Okay, so this I'm just leaving this as default right now. So coming on to kinematics. So this control parameter allows calculations to be made with force or without force options. Okay, so forces considered here are spring as well as the inertial forces. Okay, so you get two options over here. So forces on and forces off. So these forces are your spring and the inertial forces. Okay, so only these kind of forces will be either turned on or turned off using this. Okay, so right now I'm going to select as forces off so that it is a much more simpler model. Okay, so if you want to do the other way around, you can also do that. Okay. So coming on to the storage of tables option. So in this, you get various options like off, on, and log. So this on and log are a bit different. So basically, in on option, the tables will be stored, but the data you can't easily see the uh, values in the table. So to see the values, you can choose a log option, and in the dashboard, yeah. So in the dashboard, you will be able to see in this white screen on the main IPG kinematics tab dashboard, you will be able to see all the calculations that have been done in your model. Okay. So coming on to the storage of results option. So in this also we have various options that are there, that have been provided to IPG kinematics. So to explore more regarding this, let's refer the reference manual ones. Yeah. So so as I mentioned earlier, so in storage of uh, tables option, you will be able to see the result output of tables on the simulation log on the screen only. Okay. Yeah. So coming on to the storage of results option. In this, you have on off carmaker interface one, carmaker interface two options. Okay. So in this, like when the put option is chosen as on, in this what will happen is that all the files will get created, but the files will get created, but the SKC file won't be separated created, which you need to enter into your carmaker interface. Okay, so to ensure that you are creating your SKC file, you need to select between carmaker interface one or carmaker interface two. Okay, so the file that we need from IPG kinematics is .skc. So to do that, we need to choose between these two options. Okay, so going on. So car maker interface ones, I'll just go back to the in car maker interface one, so the compliance is linear, and in car maker interface two, the compliance is non-linear. So initially, you can start with car maker interface one option and then go on to car maker interface two as you are more comfortable with the software. Okay. So I'll just select carmaker interface one right now. In this, there's one more checkbox that you need to check or uncheck. So we just save carmaker files only. So as I mentioned earlier, so we only need the .skc file to input in the IPG carmaker software. So if you check this option, so only the .kin model, which is the default model that will be created after the calculations have been completed in IPG kinematics. That option and the .skc file will be created. None of the other options, none of the other files that are will be created. So if you don't require the other files, you can select this option as well. Okay. So right now I'm going to just check this option, and we'll also explore what other files will be provided if we uncheck this after a bit. Okay. So moving on to the kinematics tab. So in this, you can model the, you can like set the characteristics of parallel kinematics, steering kinematics, and reciprocal kinematics. Okay. So we'll start with parallel kinematics. So with parallel jouncing simulation type, so the left and right wheel suspension are each jounced and rebound in the same direction. Okay, so the wheel travel is in the same direction, and it happens parallelly. Okay. In reciprocal kinematics, so the left and the right wheel suspension each alternately jounce or rebound. Okay, so opposite wheel travel can be characterized using this option. So and for the steering kinematics, so if you want to model the effects of the steering rack displacement, so you can choose between the various options that are available over here. So to get more information regarding this, you can again refer to a reference manual. In this, you'll be able to specify which options do you want. So as in reciprocal kinematics, so you can see there are four options that are available. Similarly, in steering kinematics, you'll see the various options that are available. And also, you'll find information regarding all of these options in this table as well as on in the further sections in the manual itself. Okay, let's go back to our simulation control GUI. Yeah, so having covered parallel steering and reciprocal kinematics, let's move on to compression. Okay, so in compression, you need to specify the minimum, maximum, and the step size. Okay, so what is minimum exactly? So the area to be analyzed, which extends from the static position to the rebound or the droop position. So like imagine the wheel, your like for example the front left wheel. So going from the static position to the droop position. So you need to specify that in the minimum section. Okay, which will obviously be in the negative. So due to which it has a negative value. Similarly, to you need to specify the area that extends from the static position to the bump position. Okay, using the maximum tab. Um, Coming on to the step size. So in this, you can specify how accurately how many calculations need to be performed by the IPG kinematics software. So as I mentioned earlier, so like it's really important that you don't waste a lot of time in just a lot of simulation time early on in your like exploration phase. So, for example, the timeline that we are following, especially in MBA, so like right now, a lot of teams might be in the manufacturing phase. So, you need to ensure that uh, early on, so when you are exploring the models, you are just seeing if your the kinematics are good or not of a suspension system. So early on, you can choose a step size that is higher. So you can choose the step size of 10 or 7 or 5. And later on, as you are fine tuning your model, you can choose the lesser step size, like 1 or something like that. Okay. So just make sure that you input the step size according to the accuracy that you need and according to the time that you have. Okay. So because the simulation time will vary based upon step size. Okay. So
Similarly, you will also need to input the steering rack parameters over here. Okay, going on to compliance. So, the compliance and the mixed force tabs can be used to apply external forces to the wheels. Okay, so, which can be used furthermore, like to do FEM analysis on components. You can export these forces later on. Okay, so let's start with the compliance tab. So, in compliance tab, you'll see lateral force, longitudinal force, and the lateral force side percentage as well as the lateral longitudinal force right percentage. Okay, so let's start with lateral force. So with this type of simulation, so like special the forces that act only in the lateral direction. So for example, there are two planes, so the longitudinal direction and the lateral direction in your vehicle. So only the forces that are acting in the lateral direction will be either switched on or switched off based upon the selection that you do. So an example about this can be the side force that acts on the tires, okay, on the wheels. Yeah, in this also you will have like three options in when you are choosing on. So left and right. So basically, when you are choosing left and right, the second option. So the lateral force will act on both the left side wheel as well as the right side wheel. The right left hand axle as well as the right hand axle. And similarly for the left, it will act only on the left axle, and in the when you choose right, it will act on the right axle only. Okay. Similarly, the longitudinal force option can be used to to model the external forces in the longitudinal direction. Okay. Yeah. You can set the values, the minimum and the maximum values over here of lateral and longitudinal forces as per your requirements, as per your design. So now coming on to the lateral force inside percentage. So lateral force inside is like you can set the amount of lateral force on the inside wheel or like for example the left wheel as a function of the lateral force that is acting on the right wheel. So for example, if you choose, so this is the slider which can be used to change the percentage. So for example, you're choosing 100 as the percentage right now. Okay, so in this case, the left lateral force is equal to, so the force acting on the left wheel will be equal to the force that is acting on the right wheel. Okay, so choose these values based upon like the force distribution between your left and the right. Okay. Similarly, similarly, this is valid for the longitudinal force right percentage as well. Okay. So moving on to the mixed force app. So in this, you can again like so there are various options that are available. So for this, we can go to a reference manual and just so in this you can find the descriptions of each of the models that are available. So mixed force, both the longitudinal as well as lateral can be parameterized. Okay. So sorry. So yeah, this is the mixed force uh, section. This you can find the information. Okay. So move back to our interface. In this, one more thing that has been added over here is your coefficient of friction percentage. So like coefficient of friction can be added over here to calculate the load placed in the vehicle's longitudinal direction. So all the loads that are going to happen in the longitudinal direction. So you can add the coefficient of friction to calculate those over here. Okay. Yeah. These parameters can be added based upon your design. Yeah. So now that we have set our calculation characteristics, let's move on to like vehicle modeling, so or the suspension modeling. I'll just close this and I'll go back to edit. I'll go to vehicle data. So in vehicle data, you'll get various tabs, so like general, springing, then bushings, mass, and geometry. Okay. So like yesterday, so you'll also need to parameterize the masses, the inertias of each and every system, each and every force element that is present in your suspension system via these five tabs, and it will be consolidated in IPG kinematics, and a suspension model will be created. So if you remember, so we explored the 22 bodies that there are in the IPG kinematics. This. Yeah. Yeah. So in this, like we had seen the 22 bodies that there are. So you are parameterizing this right now. Okay. Back to the interface. Yeah. So now let's start with general. Okay. So now yesterday, like there was a question, like what if our damper system or a spring system is mounted on the upper wishbone. Okay. Uh, so you can address that in the springing tab by using the spring fixing. Okay, so we'll get to this in a bit. Okay, so let's start with general first. Okay, so in general, you can specify the axle on which the suspension system will be mounted on. Okay, so that is pretty basic. So you can select whichever axle you are designing this for. Okay. Like moving on to the brake force percentage. So like this is used. The slider will be used to specify the brake force distribution across your vehicle. Okay, so this is extremely useful to check the anti-dive characteristics of your system. Okay. Similarly, the driving torque ratio is the torque distribution across the vehicle. Okay, this will be helpful to check the anti-squat characteristics of your system. Okay. So in this, for example, in driving torque ratio, so like now various teams have shifted to four-wheel drive or all-wheel drive powertrain layouts. Okay. So in this, for example, you have a 50-50 torque split, okay, across your powertrain system. So what you can do is that you can select, you can just use the slider and select 50. Uh, yeah, so as the driving torque ratio over here using the slider. So coming on to the next option, which is available over here, is chassis subframe. So as I mentioned earlier, so the chassis subframe is a structure which is connected to the vehicle body on which the suspension system will be mounted on. Okay, so this this will be connected using some kind of a joint. So you there is so this is valid for commercial vehicles. So and this is not the case for Baha vehicles or the Baha buggies. So you can keep this option as off. You don't need to worry about this option. Okay. So moving on to elastic mounting steering gearbox. So in this, you can just define whether you want to choose the like elastic mounting steering gearbox or not. So basically, will it have elastic characteristics or not? Okay. So you can just refer to things that we had covered yesterday in the engine mounting like section of the car modeling. Okay, so in that we had said that it is a rigid model or a flexible model. So you can just refer back to that. It is the same thing over here also. Okay. So you can also input the two angle and the camber angle over here, and the vehicle center of gravity and the wheelbase. So these properties can be added over here, and you need to ensure that these are the same properties that you have added in the car maker geo also for. So like I'll just open the carmaker data set. Yeah. So so you need to ensure that these parameters are the same basically. Okay. In the both the sections. Okay, so that you don't parameterize the suspension system in a different manner than your vehicle. Okay, so just ensure that you don't confuse make a confusion over here. Okay, so like the thing that I was referring to before was in body, sorry, engine mount. So this engine mounting I was referring to. So you can refer to this also to get more information regarding this. Okay, so let's move back to IPG kinematics. Well, now let's move on to springing. So, like to start with, I had to start with vehicle data. I had mentioned that you can select the upper wishbone as the model where as the mounting position where your where your damper and the spring systems have been mounted on. So that wasn't an option in the MBS editor, okay, which we had explored yesterday. So to do that, what you can do is that you can just use the spring fixing option and go to upper wishbone or lower wishbone. So I'll just click on upper wishbone over here, right? Besides this, you can also specify the mounting positions of your stabilizer bar, which is the anti-roll bar. Okay, so we had explored this yesterday. So you can in IPG kinematics, you can also parameterize the stiffness of the anti-roll bar. Okay, and also you can specify the mounting position of your pull or push rod. So you can select the mounting positions over here. So if some of the teams don't use this options, okay, so in that scenario, you can just choose none as the option. Yeah. So having done with our mountings, so now we'll move on to parameterizing the stiffnesses of each and every of each of these elements. Okay. So for example, in spring, so you'll get two modes, so linear and curve. Okay. So basically, in linear, you can enter a single value of the spring rate, whereas if you select curve, you can edit like the spring rates over an entire range. So to access this, you can just click on this edit button, and you'll be able to edit the spring curve over here. So in this, you can add the compression versus the force values. Okay, in this, and parameterize the spring rate. So one thing that needs to be like I like to mention over here, and you need to be extremely vigilant about, is that the compression that we have mentioned over here is in millimeters. Okay, and the thing that we had mentioned yesterday in the spring tab under suspension was in meters. So just ensure that you don't just copy paste the same values. Okay, from the spring tab to this IPG kinematics. Okay, because it will there will be dimensional inaccuracies over there. Just ensure that you don't you enter this in millimeters. Yeah, similarly, you can also so I'll just select linear over here and go with the default value right now. You can also add the stiffnesses for stabilizer bar, the push rod, and the other options. Okay, using the same thing, so linear or curve options. Going on to bushings. So like we all know that we use various bushings in our to mount the suspension various suspension components onto the vehicle body. Okay, so you can parameterize the properties of those bushings using this tab. Okay, so over here, like you can select the type of bushing, the bushing which you want to parameterize in this section. So, for example, I want to parameterize the lower wishbone front option. Okay, so now like there is a like I have a confusion, like basically what is front and what is rear, because like in lower wishbone only there are two things, so like lower wishbone front and lower wishbone rear. So to understand this, let's go to the reference manual once, and let's go back to the double wishbone system. Okay, so because like we have like the top view of the double wishbone system over here, so in this you can see that. So, for example, I was mentioning the lower wishbone. Okay. So, in this, you can see that there are two bushings over here. So, I'll just, yeah. So, there are two bushings over here, and the lighter gray color is the bushing. The circular dot with the lighter gray shade is the bushing. Okay. So, in this, the front right would be the left would be this, and the right would be this. Okay, so parameterize the bushings accordingly. Okay, so you can refer the reference manual for this image and parameterize the bushings accordingly. Yeah, sorry, I mentioned right and left. You can parameterize the front bushing and the rear bushing accordingly as per the image. Okay. Yeah. So now that we have selected the bushing that we need to parameterize, so let's go on and select different bushings that are available in IPG kinematics. Okay. So to choose between various bushings, so you can select between these templates that have been provided by IPG carmaker, and what we can do is that you can select anyone and also go on to edit. Okay, so option, and you can edit the parameters of the bushing itself. Okay, so like various properties such as force, damper rate, and all these things will be parameters in this. So you can add these values uh, as per your bushing material, and you can just save this option. Okay, and then the file will get updated to your specific requirements. Just choose this right now as the default one. Now, okay, so the next thing that we need to parameterize is the point bushing center and the point on bushing axis, as well as the angle about the bushing axis. Okay. So to understand this, let's go back to reference manual. This you can see the bushing coordinates. The like you can specify the points, or the bushing center point is mentioned where it is located. The angle at the bushing axle is mentioned over here. So you can refer to this section to parameterize your bushing positions. Okay. So again, we had focused a lot on this part, that need to ensure that you are parameterizing the positions of each and every component extremely carefully. So please refer all the reference frames accurately. Okay. So let's go back to the bushing style. Yeah. So now that we have understood all these things, let's go to the next, that is mass. So in this, you can enter the masses of the different bodies that are available in the double wishbone setup. Okay. So for example, you can add the axle weight, the wheel weight, and all these things. As weight, not the mass. Okay, so wheel mass and everything. Okay, so one thing that you need to be there might be a confusion in new users, is that what masses need to be added for stabilizer bar, stabilizer link, rocker arm, if I don't have these systems in my suspension setup. Okay, so for this, what you can do is uh, don't select add zero over here. Okay, so if you mention zero, so you might face errors in your calculations. Okay, so just keep it as the default values. Okay, so don't just so as we have selected none over here, so by default only the system will it will be excluded from the calculation. So just don't enter zero as the mass over here. Okay, so this thing needs to be you need to be careful regarding this. Besides this, also as we have mentioned like yesterday, that these are external packages. Okay, so even MBS editor as well as the IPG kinematics, these are external softwares from which you are inputting the files to the main car maker interface. Okay, so like don't be under the impression that we have added our masses over here, so we don't need to again add that in the car maker as well, the car maker body or the car maker assembly as well. Okay, so you need to add those over there, because this is just for the calculation that is going to be so the masses that you are adding over here are just to are just to do the calculations in IPG kinematics only. That's it. Okay. These won't be added in the car maker. Okay, so just make sure that you don't do such kind of mistakes. Moving on to geometry. Okay. So in this, the first thing that we need to specify is the access system. So to understand this, let's go to the reference manual. Okay. Uh, in this, in the section of access system, you can see the access system that, which are available in on IPG kinematics. Okay, so you have two options here. So you have two options over here: the DIN option, DIN access system, as well as the automobile industry option access system. Okay, so the descriptions of what these access systems are mentioned over here. So the DIN one, in DIN one, the x-axis is in the forward direction, or the in the direction in which the vehicle is being driven. Okay, uh, only the x-axis is in the opposite direction for the automotive industry access system. Okay, so you can see in this image. So the x-axis is in the opposite direction to the driving direction. Okay, and in the DIN system, the x-axis is in the same direction as the driving direction. Okay. So IPG recommends using DIN system. So it is up to you what you want to use, but yeah, we recommend using the DIN system and parameterizing the positions according to that. Let's go back to our kinematics tab. Yeah. So in this, like now that we have specified our access system, let's move on to specifying the coordinates of each of these components. Okay. So in this, it is pretty similar to what we have done yesterday. So you will need to check the positions of all these. Uh, you'll need to check the coordinates of all these components. You will need to add it over here. Just one thing I'd like to mention once again is that please ensure that you are doing it in the same access system that you have chosen over here. Okay, so just if you have chosen DIN system as the access system, so just ensure that you are taking the coordinates in that respect only. Okay, don't use any other reference frame in which you are taking the coordinates. Yeah. So now, like we have completed our inputs that we have given to our uh, model. And so now let's close this. And now that you have completed the input data, so now you'll just need to click the start button to start the simulation. Okay. So now I'll just open one of the files that I had created earlier. So I have so as I was mentioning that like IPG kinematics will create .kin file by default. Okay, so which is only readable in the software. Okay, you can't read .skc file in IPG kinematics, so you'll need to upload .kn format over here. So I'll just start the simulation. So as I mentioned over here, so we are able to see these tables because we had chosen the log option in storage of tables. Okay, so it won't be visible like this if we had just chosen the on option. Okay. Take just a minute. Yeah. So now, the simulation has finished. Okay. So in this, you can see various uh, parameters. So, like for example, the translation. So the translation Z that we had mentioned, TZ that we had mentioned yesterday. So you can check its values in this. So the various other values can also be seen with respect to your suspension system. Okay. So also in parallel kinematic, you can see the camber angles, the two angles that are changing across the wheel travel. Okay, so this is an extremely useful utility that IPG is providing by IPG kinematics in IPG kinematics. So you can simulate your wheel travels and check if your model is like how much accurate your model is according to your design conditions. Okay. Yeah. So now Before, like I just forgot to mention that before. So before starting the simulation, what you can do is like to verify if the hard points are correct or not. So you can go to yeah. So you can go to geometrical control. Okay. In this, you'll be able to see all the positions of your coordinate systems, and you can like just verify if this values are correct or not. So, for example, like this is the chassis subframe rear. So this is the coordinate for that. So then this is the uh, coordinate where the force application on of the tire will happen. Okay. So you can just verify these coordinates using a geometrical control tab. Okay. Also, more options can be seen using this option. So in this geometry load, and all these options, you can explore more regarding this, and you can find information regarding this in the reference manual specific to IPG kinematics. Yeah. So now that we have done our simulation and the simulation is finished. So the only thing that is remaining is to save this simulation. Okay. So for that you can go to file save option and just save it any of the folders that you want. Yeah, so I'll just go. I had created a double underscore wishbone folder in my CM projects central folder. So I just save this in that. I'll just name it as done. Okay, save. Now let's go to File Explorer and open that. Just a minute. So like there's some lag in my system. I'll just stop sharing.
Rudraj, can you share your screen once again?
Is my screen visible or not? So right now it's showing that
It
I'm
is not
sharing my screen.
refreshing.
Yeah, actually able to. There is some lag with my system. Okay, yeah, it's okay. Yeah, so now is the screen visible? Is it refreshed?
It is still refreshing. We'll just wait for a moment. Until then, you can continue, Rick.
Okay, so or shall I stop sharing and then again share once again?
Yes, yes. Yeah, it is now visible. So,
Yeah, okay, so you can see the file explorer, right? Yeah.
yeah, it is visible. You can go ahead.
I'll go to double wishbones folder that I had created and which I had saved my uh, simulation results. So in this, you can see two files have been created. So .skc and the .kin file. So IPG kinematics file. Okay. So now what we need to do is that like we need to just enter the .skc file in our carmaker interface. So what we'll do is that just copy this for project folder and go to data, go to chassis, and just will paste it over here. Okay, so I've already pasted this earlier, so you can see the demo underscore front.skc file that is already present over here. So now the only thing that you need to do is that you need to go to carmaker Go to suspensions. Under kinematics, choose the model type as SKC file, and under model, select open. In this, you can see the demo underscore front.skc file has been loaded over here. So just click OK, and the file will be uploaded over there. So now you don't need to parameterize the kinematics in the car maker or the vehicle dataset present in a car maker. You can do it using IPG kinematics. Yeah, so I also mentioned the like I just opened the simulation control once again. Yeah, so I also mentioned that like I had like chosen the I had checked the save car maker files option, okay, earlier. So now let's see if what happens if I don't select this. So I have already created a file regarding that. Okay. So yeah, in this you can see the various files that are created if you don't select that option. Okay, so like as like ATS team also mentioned in the storage section that like there's no need to save unnecessary data. So to optimize your storage and to have a few files as possible, and you don't need to do like you don't need to store a lot of files in the initial phase when you are parametering where you are parameterizing your suspension model in IPG kinematics. So in those sections in the early phase you can just stick to .skc file, and later on you can use the other things also. So like you can refer to these files as and when required. Okay. In this, the .skc file will also be created. So you can see the demo underscore front.skc. This file will also be created over here. So yeah, that's it from my side. Over to you, Aditya.
Yes, thank you, Ruturaj. Yeah, so just a quick like a side note regarding the questions which we are getting. So that regarding the tire rate, so it is the like vertical stiffness of your tire when your model is like when you model your tire as a linear spring. So you can go ahead, do your calculations and come up with the tire rate, and you can enter the value in IPG kinematics. Yeah, regard this question regarding do we need to add weight and other factors in car maker. So this was covered in this session. So I'll reiterate once again that although you have entered the values in kinematics or like IPG kinematics or MBS editor separately, still, so those are just used for your calculations. That is the dynamic calculations of your system when it will run on tracks. So when you link your let's say SKC file or MBS file, so it just gives the kinematics of your vehicle. So but for the kinematics to work when the vehicle is running, the masses have to be entered in the assembly and body tab, like which was covered yesterday. So those have to be explicitly added. Regarding how to make an SKC file, that was covered in the training session. So it is present in the like in the general tab, like in storage of results. So you can go ahead and select how you want to store your results. So if you select the interface one, it will save as a linear model. But if you go for two, it will go for a non-linear model. So it is depending upon your choosing. Okay, so this was the first part of the virtual vehicle environment, which is the parameterization of your vehicle model. So upcoming next, we'll go into the other aspects of your virtual vehicle environment, which are the maneuvers and which are the maneuvers and IPS driver. So which are the control system of your vehicle. So over to you, Sushant. You can go ahead and share your screen.
Yes, sir, definitely. Is my voice audible, sir?
Yes, yes, it is audible.
Okay, thank you. Is my screen visible?
Yes, you can go ahead and like start your presentation.
Okay. So, hello everyone. Uh, my name is Sushant, and I will be explaining you and moving you through the uh, manures and drivers. So basically, a thought comes into mind since since you all are doing the session from last day. Still, I'll be putting more focus on what can be the manures. So as you all know that manures, we can look into manures through this by clicking this parameters option and going on to the manures. So this is the manure tab as you can see on the screen. But let me move you through the main what you can say what can be the menus. So basically a maneuver can be moving a car carefully over a specific position or a particular place. So basically I will explain it by taking an examples. Like suppose we are having a road of 200 meters and we are having a turn at just start of 50 kilometers. So what can be the maneuvers for it? Like at the start, driver will press the accelerator pedal and move on the vehicle with a particular speed. Then since there's a turn at 50 kilometers, 50 meter ahead, so driver will just apply the brakes and decelerate the vehicle up to a certain limit and take a turn and then again accelerate and complete the track. So whatever things I said, this can be said as menus. So basically we'll be starting with all the complete functions as you can see on the screen. Like there are five different things which you are going to look about. The manure complete manure tab, then specifications, then longitudinal dynamics, lateral dynamics, maneuver command. Since ATS team has covered most of the things about it, but still I will be pressurizing on how we can implement this IPG car maker options more into Baha. So let's start. So label is nothing but a short name that is given to a certain manure. Description, as we can say, whatever we write here in the description box, it will appear automatically on the screen here, as you can see on the screen. Like speed control I have written here, so speed control is automatically getting placed over here. Like if I have written IP driver, let us say we are writing something different, like we say acceleration, so it will appear on the screen, right? So like this we actually do it. So what is the main idea behind putting the description? Like if you are having a track of more than a kilometer and you are giving certain 20-25 menus, to remember what exactly the menu is given to what kind of conditions or situations, we write actually the descriptions. Next we have a end conditions. So what can be the end conditions? At conditions is nothing but how you are ending a particular uh, manure that were given to a vehicle. Like we have something called as car dot road dot s road less than equal to suppose 100. So this is the end condition which says that the maneuver will get over when the distance is reached less than equal to 100. So just by right clicking you can browse uh, many menus as you can see on the screen. Just by clicking any of the menus you can go and search for it. So basically this was the idea behind end conditions. There's option for duration like time and distance. So time, it will specify duration for a particular manure, and distance, so whichever thing ends up first we'll go with that manure. As suppose if the time ends up first, like 0.5 seconds ends up first and distance of 6 meters ends up later, so maneuver will complete with go with the time only, whichever ends first. So this was the specifications of manure step. Next we'll move on to longitudinal dynamics. So there are many such options in longitudinal dynamics like IPG driver, speed profiles, control, as you can see on the screen. But what is this IPG driver? So IPG driver, we can say that it's the human driver which will maneuver the vehicle on a specific track uh, by using the vehicle limits, and will maneuver without your command. If you haven't given any condition for turning or braking while taking a turn, the vehicle needs to brake. If I haven't given that braking maneuver, still this IPG driver, what it will do, it will apply the brakes, and then it will again try to reach up to its uh, top speed that is given in the system, or according to the user driver. So this is basic idea behind IPG driver. Likewise, we have a speed profile. uh, in speed profile, there's a manual gear shifting, automatic gear shifting means manumatic, and start with speed profile from beginning. And next we have a speed control. Let us suppose in the given parameters we have a max speed of 50 kilometers or 60 kilometers per hour, but we need to uh, on a specific track we need to have that speed. That speed means a particular speed that will allow the vehicle to follow the path in between. It will not go out of path. Like there's a speed limit for 40 kilometers per hour. So if you are putting 40 kilometers per hour here, so it will follow. It will be moving with 40 kilometers per hour only. It will not go beyond it. So it is like that. Then there's some maximum deviations. What can be the maximum deviations? More or less can be applicable there. And sensitivity, if suppose we are switching between the two maneuvers, and we have a sensitivity rate of 0 to 1, like the second maneuver has some speed of, assume it to be like somewhat 20, and we have given a sensitivity of 1, so it will switch over to 50 kilometers per hour at an instant rate if you are giving it the sensitivity as 1. But if it is 0.5 or less than 1, then it will switch over smoothly. The same with the pneumatics and gear shifting. Gear shifting means if your vehicle has a gear shifting thing, then it will do shift the gear on its own, reaching its particular speed. But if you haven't specified, if I have unticked the box, then it will be remain in the same speed. It will not change the gears. Likewise, we have a speed transition. The same thing. Uh, it will transit the speed as you will, whatever you specify here. Like in transition, it can be linear, cubic, sinus, step, and rate. Next, we move on to the manual pedal gears. Yes, so before we have discussed about the speed control, the IPG driver, which will be moving on its own. But here's an easy option, an important option for the teams to manipulate the values. Like we have gas, clutch, brake, brake park, and gear. So it allows the values from 0 to 1, and will take over whatever will command. 1 is the most, 0 is the least. So whatever you command here, it will the vehicle move on your command only. Then we have the stop the vehicle. As you know, it's simple. It will stop the vehicle or decelerate the vehicle, whatever rate you put in this tab. If we have a drive backward, like at a certain in a certain track, in a certain maneuver, when you are applying this command, it will stop the vehicle, and then it will drive the vehicle backwards, and whatever accelerate you put here, it will move according to its speed and acceleration. Yes, and this is the most or what you can say is the important option, like IPG driver and user driver. Like IPG driver, as I explained earlier. But now what can be the user driver? User driver is such that you have to apply your own parameter manures, or what we can say, your own idea, and you need to make your own file that will be running with this IPG driver. Means, what is the main idea behind it is that uh, for particular manure, you have you have not given some menus for a turn, or left or right turn, or whatever you can say on cornering. We haven't given any menus. It is running on IPG driver, but you want to reduce the lap time and during the cornerings. So IPG driver will go with the human, means human menus only. But if you are the user driver, you are having an experience ki what can be done while turning, how to reduce the lap timing. If you are doing some changes in user driver, so it will whatever there is, whatever the manure which is reducing the lap time, initially it will take that file, initially it will take that thing only, like if it goes with the user driver. So this was about the longitudinal dynamics. So I'll be showing each and every some of the options uh, in the menus on later stages. But let's now move on to lateral dynamics. So I'll be covering some each and every part of it, but in uh, not much in deep, because ATS team has already covered. But yes, I'll be explaining you the complete simulations, each and some of the points very clearly. Like in lateral dynamics, if we are talking about lateral dynamics, it we are mostly talking about cornerings, yes. But in longitudinal, we are only talking about the straight path, where we are using clutch, brake, acceleration, etc. But in lateral dynamics, we are majorly focusing on cornerings. Like we have a sinus sweep, steer step, follow course, and other things as you can see on the screen. Like sinus is what? Sinus is what somewhat like the vehicle will follow the sinusoidal path, whatever you specify, like starting from the whatever time you specify. Amplitude means the degree of turn you want to make through the steering wheel, not with the tire. Okay. Period means for how much interval of time you want to steer the vehicle, and periods means number of repeating periods, after how much interval time it should repeat. And the phase offset, of course, it's a simple thing. And then we have a smooth transition, and or steer by torque, or Wellian offset. Then again we have a sinus sweep. Sinus sweep is somewhat same thing, but we can have a sinusoidal uh, movement of a car in ascending or descending. By changing these values, we can also simulate in vehicle, like turning one one with 30, first with 30, then again with 250, somewhat like this. Okay. Okay, so this was all about the IPG drivers. Yes, yes. There's a step steer also. Steer step. Steer step means at on like if you have a cone like thing in between, or sudden bump in between, there we can use the step steers to steer the vehicle instantly. Here we can specify the degree of angle and the duration for what interval of time we can have this steer step. Then there's a follow course. follow course means we'll be following a course, means following the center line. Tolerances, as you can apply, so it will, as you applied, the tolerances should be 0. So it will follow only the center line. And if you have some tolerances in somewhat like more than 0, 0.1, 1.1, uh, 0.5 something, so it will deviate from the center line somewhat. The same lane change, as the name specify, it will change the lane after giving the specific command. Then we have a lane offset. In a particular lane, if the vehicle is moving and you want to apply some offset from the center line, so of course uh, it will take the command, like if you have 2 3 or something meters from the main lane, so it will deviate 2 meters and will cover up the path. So this was all about the lateral dynamics. So before moving on to the IPG driver, let's have a complete and clear idea about whatever we have just done here. So I'll be just opening again. Okay, let's start. So as you can see on the screen, the we have applied so many things like longitudinal and lateral as well. So in lateral, we are covering the steep steer, sinus sweep, etc. And in longitudinal, we are covering acceleration braking. Okay, let it complete. Again, I will reduce the speed and will explain you what is happening. Like this vehicle has started, right? Just have a Teams, please just have a look at this manure window. Whenever it is crossing some manure, it is going on to the next step. Again, I will do it. Whatever I have written here, like we have an acceleration, then speed control or speed transition sinus. Just have a look at it. See, now there's a speed control, then there would be sinus. Speed transition sinus, as it watches the bump, it takes the sinus command. Then there's a step steer in this. Then we are moving with the IPG driver. It will take the commands or run on its own. Then again, there's a speed control, controlling over the corners. Still, we have kept the same speed around 18. It will not cross the 18 kilometers per hour, as you can see here. Then again, there's a free path. It will take up the acceleration to optimum level. Then again, it took brake. And yes, here's the menu is completed. Now again, I will just move back and show you how it is doing the braking. See, I'll just reduce the speed. See, it applied some brakes, then again it is moving. So what is the idea is, main idea behind this manures is you can refine these manures on your own by using this lateral dynamics and longitudinal dynamics and this end conditions, durations, time and distance. You can refine it. The older teams must have a clear idea about IPG means these dynamics, but they can refine it by moving on to the driver parameters. And yes, for the new teams, you can have a better knowledge of it by going through the manuals like user guide we have. Then we have reference manuals. Like in user guide, for looking more deep into the manuals, we can just switch into so here's the in the user guide, you can have a complete detailed knowledge about these menus, what all specific tabs we were talking about and how it was working. So you can go through it, user guide. I know that it's around 910 pages. A reference manual is about 110-15 pages we have. Then we have a IPG driver as well with us, having 162 pages. But teams do remember one thing, that there is no better learning if you don't have a base of it. So that is why if you're iterating it so many times, it will take time. But if we'll be going with the manuals, user guides, it will take a bit less time. So teams, it it's up to you how you're going. Then again, we'll come back to the driver parameters. Yes. So here is the driver parameters. So driver parameters, this tab generally has two modes like user parameterized driver, racing driver as well. So user parameters driver is nothing but where you have the options for refining the menus more further. Okay, like we have a cruising speed, change in the timing of paddles, corner cutting coefficient, minimum change in time for acceleration and deceleration. Okay, so cruising speed, in our case, we have 60 kilometers per hour as the maximum limit set up by the as per the rule book, and change of paddles. Like in Baja, we have two paddles that is only situated at the uh, right side, where you have to apply the brakes uh, with your 1 foot only. Okay, so you have a brake pedal and the accelerator pedal. So if you are putting here value as 0 to minimize the lap timing, then it is also okay, but it's up to you how you're maneuvering the vehicle or a specific path. So we don't recommend that to make it is 0, but yes, it's up to you. But just to reduce the lap timing, you can do it. Then there's a minimum time for acceleration deceleration as